Hello, and welcome to today's webinar, which we are hosting together with our partner with the name GPS Partners. So I see that people are still joining the webinar. So let's wait additional 2 minutes, and then we will officially start the webinar. Thank you. Okay, I think most of us have successfully joined the webinar. So my name is Vit Peterman. I work at 3Dsurvey since the start, and I am joined today with our newest partner, Mr. Ieraksts. Ieraksts, can you say a few words to the webinar attendees, please?
Yeah, thank you, Vit. I will tell everyone some words in Latvian, so yeah, and then we can start presentation. Paldies visiem par mūsu webināru apmeklēšanu. Prieks visus redzēt. Šodien 3Dsurvey speciālists Vits pastāstīs par programmatūru, par fotogrammetrijas programmatūru 3Dsurvey, par softa iespējām un arī parādīs diezgan daudz smuku piemēru. Webināra ilgums būs līdz stundai. Webinārs būs ierakstīts, līdz ar to, ka jums nesanāks noklausīties līdz galam, mēs pārsūtīsim jums ierakstu. Droši rakstiet jūsu jautājumus čatā, var arī latviski, mēģināsim atbildēt, vai arī vēlāk e-pastā. Kā arī jums ir iespēja lejupielādēt 14 dienu izmēģinājuma versiju, softa versiju bezmaksas mūsu mājaslapā. Vēlreiz paldies visiem par piedalīšanos un došu vārdu Vidam. Okay, Vid, yeah, you can start. Thank you.
Thank you, Ieraksts. Okay, we are ready to go into the presentation. So 3Dsurvey is a photogrammetric software for processing of aerial images. And from these aerial images, we produce 3D data. So we developed 3Dsurvey based on the 10 years of experience. So we actually started using drones for land survey back in 2011, directly when me and my colleagues finished universities. So then we thought, let's do something different in land survey. So we started doing orthophoto maps and doing survey maps like that. So we wanted to make 3Dsurvey special and stand out. So we decided that our software solution will not be only photogrammetry solution, which can create orthophoto and textures 3D model, but we also wanted to add data analysis part to the software. So that means that from this data that we create, we can get to the real data that you need to give to your clients. So we have things like integrated volume calculations, integrated CAT engine, ability to draw survey maps, and these kind of things. And everything is included in one package solution. So everything that we'll be talking about today is part of 3Dsurvey package. So the idea is to have all the functions that are in here, all the things that land surveyors need, included in one software solution. And now, okay, Now I will go directly into product presentation. So I will show you how to process a data set with some aerial images in 3Dsurvey and what kind of data we can extract from these images. So, right, let's minimize this one. And here is already 3Dsurvey, our software solution. So we begin processing a project by clicking on New Project here. And now I will select some aerial images. So for this example, I have a very small data set of 33 or 34 images. So when we select the images, the software also asks us if we want to import telemetry information. So for 99.9% of the users, we leave this one on EXIF data. So the drones, they write the telemetry information into the images themselves. So this is called EXIF. And here we just set up our coordinate system. So this example here is recorded in Slovenia. So I select Slovenia coordinate system. I was looking at, we are redoing the coordinate systems now. So we already have a new version we are working on now. So I was looking into your coordinate system. Important is to select the correct one here. I don't remember exactly, but I think yours might be LKS 92, or maybe I mixed that up now. And here you have to select the correct GeoIT model. So for you, that will be the Latvia LV14V4 GeoIT model. So this is how we set it, how we set everything up. Must change this one back actually, like that. And then we press import. So the software reads the latitude and longitude information that the drone stores into the image, and it converts that to our state coordinate system with our state elevation model. Right. So that means everything is set. Here we see where we flew our drone. And now we get to the first step of processing, which is completely automatic. This one is called bundle adjustment. So just switch here to some random image so that while bundle adjustment is running, I can explain how it works, right? So this is one of the aerial images. We will start bundle adjustment now. With the default settings, it is fine. So now when bundle adjustment is running, software goes through the images and it finds interesting points in the images. So these interesting points are usually some kind of blobs or some kind of corners. So the software calculates some special descriptors for these points, and based on these descriptors, it finds same points in different images. Once we have same points in different images, we can calculate how these images were recorded in one in relation to the other. So we can calculate better orientation of these images. And as a result, we also get what is called a sparse point cloud. So this is how a sparse point cloud looks like. So these points that we see, these are these points that were identified in the images, and the same points were found in different images, and based on triangulation, we then get these 3D points. So now comes the second step, which is actually already a little bit optional now with the technological advances. So the second step is called orientation, and we have different versions of how we can achieve that. This will depend on what kind of hardware do we use. By hardware, I mean the drones. So today, most people work either with DJI Mini or a similar drone, or second option is enterprise drone like this Mavic RTK drone. So this is DJI Mavic 3E RTK. So the price of this one is approximately 1,000 euro plus tax. And this one, I'm not sure, it might be I think 4,000 or 4,500 plus tax or something else. I forget the numbers. The main difference between these two is this one has an option for RTK georeferencing, and very importantly, it has a camera with a global shutter, and it has the ability to fly along the pre-planned route. This one, on the other hand, is also suitable for some smaller tasks. The downsides are it has a rolling shutter camera. That means when image is recorded, it's recorded line by line. And when the image is recorded, it creates a special kind of distortion. I have here a video in which I can show this distortion. So I think you saw this kind of pictures before. So this is result of video being recorded a line at a time. So here on the left, you see global shutter image, and on the right, this is a rolling shutter image. So if we have a rolling shutter camera, that means for each picture in our model, we also have to calculate how fast the drone was moving in order to eliminate this rolling shutter effect. We can do that, but in the end, it is still a lot better if you have a drone with a global shutter camera. And then the second added value of this more advanced drone is it has RTK GPS on board. That means that we have more accurate positions where the images were recorded. Right. Okay. Now let's go and have a look at how we can georeference this data. So the best way to georeference any kind of photogrammetric data is with ground control points. So even if we have an RTK drone, that drone will have GPS on board, but if we want 2 centimeter accurate elevations, so let's say 2 to 4, what surveyors need, we will still need between 1 and 4 ground control points per flight. If we have a drone that does not have RTK GPS, then we recommend you place between 6 and 9 ground control points per flight. And here in orientation, we will be now marking those ground control points. So I'll go now orientate with GCP data. So the first step is we import the file with ground control point locations. So that file is just a TXT file. Let's open it so that you see how it looks. So it's just point name, easting, northing, elevation. That's it. Press import. So 3Dsurvey has the ability to recognize certain predetermined targets. Most of the time we use either circular or checkerboard targets. And if we use this, then the centering of the ground control points can be done automatically. So we'll press here, I will leave this one on circle and press next. So this data was recorded by a non-RTK drone. So in this example, I have to zoom in and just mark 3 random ground control points. And then the software will figure out the rest on its own. So here is the second one. And here will be the third one. After I mark these 3 ground control points, software figured out automatically which were the ones that I clicked. And this one, number 10, that we did not mark yet, approximate position of this one is already known. So this is now just approximate position. Now in the next step, the software will go and it will search inside of this circle for the center of the black dot. So if I used an RTK drone like Mavic 3E, the marking of the 3 initial ground control points would not be necessary, because this would already line up automatically. Now we just press next. Oh, wait. Maybe we just need to improve it slightly, because I think I did not click one well enough. I'll just say number 10. Actually here, I think some of them were too close to the edge and they did not get detected well enough. Now when I press next now here we have the automatic detection of the ground control points. So here we just need to go through the images and check that every image is nicely detected, so that here it did not go on some GPS antenna or something like that instead of the black dot. And when we confirm that everything is detected correctly, we press next. And now this information gets added to our photogrammetric model. And as a result, we get here what we call ground control point errors. This is the difference between where we measure the points with GPS and where these points are in our photogrammetric model. So the final accuracy of the results would probably be average of these values. But from practice, from practical experience, I can tell you that what we usually do, we just usually look at the highest ground control point error, and then we say the final accuracy of results is probably as much as the highest error here. So in that case, this is now about 2 centimeters. The usual guideline is we check for this ground control point error. So, and if here we see a value like 3 or 4 centimeters or more, in that case, you would go back and you would check how that ground control point is defined, maybe improve the centering of that ground control point manually, and then repeat the orientation until you get it down to about 2 centimeters or maybe 3 centimeters. Right. Now I will press finish here, and now our model is georeferenced with these ground control points. Now the next step is in processing will be reconstruction. Reconstruction is the part that takes the longest. As a setting, we set here either high or medium usually. So the general guideline is we use high when our results are 3D, so when we are doing a 3D survey map or when we are calculating volumes, and we use medium when we are working, when we want to create orthophoto or more 2D result. In any case, this algorithm runs on GPU, so it helps if you have NVIDIA GPU. If you don't use this checkbox, then CPU is used instead, but results are nicer with GPU-based calculation. So on high setting, it takes approximately 1 hour per 100 photos. So here we have 33 images. That would take approximately 20 minutes. So that we don't wait for this to finish, I will just cancel here and go to point cloud, load, and load a pre-calculated point cloud. So which one will be, I think, let's see. Every time you calculate a point cloud in 3Dsurvey, the point cloud is automatically saved in a certain folder. So now let's just check that I have calculated the one with the correct elevation model. This one is, I selected the wrong one. I think this one will be the right one. Yeah, this one fits to the ground control points. Right. So when we get to the point cloud, the first step should always be point cloud classification. So we'll go here, classification. And the classification in 3Dsurvey is semi-automatic. So here we have some settings for classification algorithm. So let me explain it a little bit better. So we are now classifying which points are ground points and which points are all the other points. Because from the ground points, we will be creating our digital terrain model and calculating contour lines. And it's also needed when we are calculating volumes. And so here are the parameters for classification. So the most important one is terrain elevation. So that tells us that we expect the neighboring points to have a maximum 5 centimeter difference in elevation. So I'll just press next here, and then some calculation is ran on in the background. And then the software only wants me to select one point on the ground. And when I select point here, it selects all the points that have similar elevation, so that the elevation between neighboring points did not change by more than 5 centimeters. And in that way, it found way in here and selected all the points with the similar elevations. And then when we click next, then a second step is applied, filtering, which leaves out all the small bumps. So basically in this step, a surface is generated from the selected points, and the points that are only lower or only a little bit higher than the surface are classified as ground, and everything that it is considerably higher is classified as non-terrain points. Now we'll press finish. And now our point cloud is split into ground and other points. So these are the ground points. They are colored in red so that we can better distinguish them from the others. If we press clear, they revert back to their original colors. And now we will create our digital terrain model. So we'll go here, mesh, new regular grid mesh, from ground points only. For example, 1 meter grid cell size, and press calculate. Okay, so now we have this kind of digital terrain model. So digital terrain model is perfect data to extract contour lines from, for example, with 0.5 meter equidistance. It's also perfect data to calculate some volumes from. So if I just manually select an area like so, and press calculate volume, so now initial surface will be interpolated and final surface will be the one calculated from point cloud. And already we have a volume here saying that we have here about 1,000 cubic meters of material. If I go here into volumes, we can actually check what the height of the pile of material is. So here we have about 4 meters of material. But we will look at more volume calculations later. So now I will go back to mesh. We will temporarily turn this volume off. And from this mesh data, we will also calculate on orthophoto. So I go here, orthophoto, calculate new. The most appropriate resolution for our orthophoto, which is similar to the resolution the images were recorded at. So that means about 2.33 centimeters per pixel. So let's press calculate and let's wait for this one to finish calculating. So first images are being reprojected onto this digital terrain model and being dewarped. changed to orthographic projection. And then in the second step, color between images colors are harmonized, so that when we create an ortho mosaic from our aerial photos, it will be hard to tell which part of orthophoto was calculated from which image. So after important phases in the calculation, you saw it went autosave. So after you calculate orthophoto, we create autosave so that we save the work. So now here in the orthophoto, we see contour lines. If I turn the contour lines off here, then they are also gone in the orthophoto. So this is now our orthophoto. You see it consists of these kinds of pixels. So a pixel size in the nature is about 2.33 centimeters now. So this is the value that we think works pretty well because it allows us to still see any kind of detail that is interesting to us as land surveyors. And we don't get too big orthophotos and too much data. So, right, one interesting thing. So here we can see this car which was moving. So here we actually have an option to select this area here. And for example, say we will use a picture here like this one, where there is no car visible. So select this picture here, press confirm, and select recalculate. And now this second picture will be draped into this area, so that, and in the same way, you can also remove people or cars that are not parked, or trucks or excavators or anything like that that is moving. Right. And okay, we don't have any car present in here anymore. So this is data. So we have here orthophoto, we have here our DTM, we have here our point cloud. The one thing that's missing, we can also calculate full 3D mesh. I'll just go here, project open, and I will open a project with full 3D mesh calculated as well. So when I say full 3D mesh, this is how full 3D mesh looks like. So this is our DTM. I'll just write here DTM as in digital terrain model. This one contains only ground points, and it's calculated from regular grid. So it has 1 meter or half a meter grid resolution, whatever we set. Full 3D mesh, on this other hand, this one is more useful for visualization. So it has an irregular network in one location. So you have the ability to have here for this position here, we can have different elevations for a certain position. On the other hand, here where we have regular grid mesh, this one is more 2.5D. For this point here, only one elevation is possible. We use this for visualization purposes, and we can also draw on it. Right, and we have our point cloud. So all of this data can be exported. You can just right-click here, press Save As, and select which data format you want to save it into. Most of this data can be imported into CAD softwares, like Point Cloud can be imported into AutoCAD and BriskCAD and some other CAD softwares. 2.5D meshes can also be imported in some CAD softwares. So we have other webinars on our website where you can see that, how the workflow for that is. And of course, orthophoto, if we save orthophoto, we have various georeferencing options. Usually we use WorldFile. We also have option to write DXF frames. For TIFF files, we have the ability to write georeferencing information into GeoTIFF data, so that when you import this data then into GIS or CAD softwares, they come in at the right location. So now we looked at the basic photogrammetry part. So this is creation of the 3 most basic data types. Now I want to go into a little bit more details, and I have already here opened second project. Let's wait for it to load. So in this second project, I will show in more detail how CAD functionality works in 3Dsurvey. So here I just have some data already set up. I'll just right click here, remove texture. Right, point cloud is currently not visible. We will turn it on. Currently the ground points are selected, so because of that they are colored in magenta color. Press like that. So, and here we don't have orthophoto, we will just delete this X-ray. Yes. So, okay. The most common tasks for land surveyor are production of survey maps. We still need to produce line drawings that architects or government institutions recognize and know. Now, one of the functions that is available only in 3Dsurvey, and it helps a lot to make extraction of buildings easier, is called X-ray. X-ray means we create a orthophoto-like picture where we get white color there where we have vertical walls, and we get transparent image where we have or black image where we have horizontal surfaces. So this is how this castle now looks in X-ray. So now I will go here to mesh, and I will drape that X-ray onto my digital terrain model. Like that. The purpose here is to extract the outline of this building. And you can see here in X-ray, the wall here is in white, and we can actually see it very well where it comes through the roof, because otherwise on the orthophoto, you see the roof goes over the wall, so we would not be able to see where the wall is. So I will now go into point cloud, and I will temporarily disable the point cloud and go into CAD now. And now I will double right click here to zoom in on this location. And now we get to time. So let's start drawing the outline of this building. So I will press here on the first column, first corner. And when I select here a position, we automatically get easting, northing, and also elevation. And elevation comes from the digital terrain model. So we already have the elevation that we want. Now, if I zoom in here, I can see and I can improve this 3D position a little bit more. So here on this side, we have the original images, and if we remove a point on image, we can actually get to accuracy, which will probably be even better than when we use the total station to measure the corners. So here you see that the base for the castle, it goes slightly out to the outside. So basically, when I select a point here, if I want to be very accurate, I need to take the outer edge like that, and just maybe move it slightly here. And so I'm now talking and showing how this is done. So I'm slightly slower, but in real life, if we do this, we can be very, very fast marking the corners. So here the situation is a little bit more tricky. You notice I don't see in this first picture very well this position. So when that happens, I just rotate the camera view here, and software automatically selects a picture that sees this point from similar angle. So if I continue like that, I can now very quickly and effectively digitize this whole building. And actually this roof was digitized in the same way. So then when we are done with drawing these outlines, we can go here to data, save CAD as, and we just save those line drawings into, for example, DXF data format. Right. So the time is flying by now. So if during this presentation you get any kind of questions, you will see that there in the GoToWebinar tool, you have a section where it says questions. So if you have any kind of questions, please set them in there, and at the end of this webinar, we will answer them. Right. So now I want to go to the next part of presentation, and now we will be talking about how 3Dsurvey can also be used if you are calculating volumes. Again, I have here another 3Dsurvey project, and in this project I don't have any pictures. In this project I only loaded 2 point clouds. So this is point cloud first measurement and point cloud second measurement. And what we will be doing is we will be calculating the volume of the excavated material between these two measurements. And this is what the area looks like. Right. So these point clouds already contain only ground points. So here all we need to do is just create 2 digital terrain models. Let me set this one to all. So setting of the extrapolation to all means that we get that we get also area around here, which is white. So this is extrapolation. It's not very accurate, but at least we have some elevation there. And DTM for second measurement. So we see here where the elevation did not change, we get this kind of interesting effect when we rotate the model. That's fine. We can move in between the two. We can color one. For example, make the second one blue. And turn on shading. And then we can play with bounding box. And we can see how the elevation changed. We can actually even move inside of the volume and see it from here. So I'm showing this off because the volume calculation is so fast, so that we have something to do. Turn the bounding box off. Right. Now, in order to calculate the volume of area of interest, we first need to define the area of interest. So one way to do it is like we did it initially, when we press select and we just drew where we want it. But better way to do it still is to have this defined in a CAD line. So I will just now load a boundaries file I have here in DXF. In this case, where is it? Okay, maybe let's try it one more time. I think it's not showing up because I have bounding box enabled, and it's only showing now what's inside of the bounding box. So press reset view, and now I see the boundaries here on 0 elevation. Right. So these are on zero elevations because this is the data that we received from the civil engineers. If we want to see where that is, we just go top down ortho, and this is where we will be calculating our volumes. Right. Now we go into mesh, calculate volume, select which is the initial surface, which is the second one, and then select here from CAD. My boundaries are on layer 0 because it's from AutoCAD. Press calculate. And software automatically selected the areas inside of this boundary. And okay, because I loaded boundaries twice, we have each one twice. So I'll just write here, this is the excavation site. And this one is the stockpile here. And number 3 and 4, we will just delete. These are because I loaded DXF twice, so we have 2 lines. Okay, so I should actually go to CAD, select this line and press delete. It's deleted, and go here and delete the duplicate of that one as well. Right, now we'll go here into volumes, and this one we will just delete, and this one we will just delete as well. Right. So our volumes are now here, and we can see for each one what the surface elevation was before, what was after, and what we have, what is the difference, so cut or fill. Right? So whenever we are calculating volumes, we also need to create some vertical cross sections. So we create the vertical cross sections here in the point cloud tab. So just temporarily, we will turn the volumes off. Go to point cloud. And then when we calculate profile, again, we have an option to define these profile lines through CAD, or we can just define the profile lines definition manually. I will do that now. So the first one we will draw like that. And now we'll select the second one. And maybe the third. Okay, this one will be a little bit like that. So when we draw the profile lines, automatically we'll be able to see them here in the 3D view. And they will also show up here in the profile view. So these profiles, we can export them into DXF or PDF, and we can also annotate them. We can also create points on the profile, and I can select, for example, this one and write top of pile, second surface. For example, this marking of points, this is actually more useful when we have a ditch and we want to mark the bottom of a ditch or a top, when it goes like that. Mark here, this is top, here is bottom, bottom, top. So when we mark points here like that, these points will be here in our CAD section. So these were the points that we marked on the vertical cross section. So right, now we have a few cross sections, we have a volume calculation. What we still need is to produce a report. So we'll go to project, generate report, generate measurements report, select which volumes to include, and press calculate. Now a Word document will be created, which will include this basic information about the volumes and the cross sections. So here we have information about where we did the first volume called excavation, and then the second volume, the stockpile, and how much it was. So what was the fill? So how much material was added to this stockpile? How much material was taken away? Because of course, when they were digging it out from here, they were putting it here, and from here they were driving it away to another location. So we get fill, cut, and knit difference. And for vertical cross sections, we have the cross section position and what that cross section, how much it is. So, you know, because every time when you do volume calculations, when you get to the people who are paying for the excavation, they want to check and they want to see, okay, for this area here, we had excavated that, and so the elevation changed by that much and that much. So, right. Okay. So in 1 hour, it is impossible to go through everything that software has to offer, but I'm just trying to go through the most interesting functions. So finally, when you finish your project, you now have here this nice 3D data that you work with. And you can get them into AutoCAD or QGIS. But we surveyors, we are also working with civil engineers, with architects. So maybe in their software, they will not be able to bring point cloud in. So then we added with the in 2023, we added the ability to upload our projects into cloud. So after you finish processing your project, when you draw in here lines, put in X-rays or whatever, you go here, select cloud upload, select which data you want uploaded, and it will take a while, and then it will go into 3Dsurvey cloud. Let's see how that looks. So everyone gets 75 gigabytes of memory. And let's open this example of a random project. So when you get here to the cloud, you then have ability, you can click here on share, you can select anyone with the link can view the project, and then you can give this data to architects or civil engineers. So, and here on the cloud, data is loaded like so, point by point. When you zoom in, depends on the internet speed as well. And then here we are able to, for example, measure the height of this building. So if we do like that height measurement, it only takes the height. So we can see that it's approximately 7 meters high, depending when where we take our base. We can draw some other lines. We can, so here we also have full 3D mesh calculated. I'll turn the mesh off, turn the point cloud off, and this is the full 3D mesh of this village. We have the ability to add some annotations in here to draw some points. And we can switch between 2D and 3D views. So this is now the orthophoto view. In this example, I only have one measurement. If we have multiple measurements per survey site, you're able to also see that. Let me see if I have an example here. Before, after, maybe. Yeah, just want to show also this one. So here in this example, I think we have 2 point clouds. So this is the first measurement. It was done on 1st of June. And the second one was 1 week later. And then like that, we are able to see how the terrain changed between those 2 dates. So now we are having a webinar presentation. So that means that whatever I say gets sent over the internet to you. because of that, the cloud works slightly slower because we are using bandwidth for Vebināra as well. So if we go into 2D view, this is also interesting. Here we can, if I zoom in, we can also see here how the area changed during that 1 week period. Right. So this was now very fast presentation of 3Dsurvey capabilities. I have more things to show, but I think it will be enough for the first webinar. Now I see that we have some questions. Let me have a look. And I see that we have a question here. The question says, what's your suggestion for getting surface data in ditch bottom under the water? Well, under the water it can be difficult, you know, because if it's a ditch and if it's water inside, so probably there will also be a lot of vegetation. So what I would do then, if I had a ditch there, I would want to have at least a few points measured with the GPS. So for example, let's say this is my GPS point. And if there is a water in ditch, this point will come up when we will compare it to point cloud. It will come in like so. I will just select the point here. And I will just manually change this one. For example, I will lower them by 20 centimeters just for demonstration purpose. So I would check these points and I would see, I would go here, I would check, okay, my point was measured at 30 centimeter elevation and the other points here at approximately 50 centimeter elevation. So if there is a ditch going here and I would take these ditch points from point cloud, and then I would select all these points and I would lower them by the same amount, about 20 centimeter. The same goes, like here we have high grass. If we want to create a digital terrain model of an area where we have high grass, the best thing to do is to go to point cloud. I would select this area here. So in the same way, I would measure some checkpoints, and then I would just select these points, select here manipulate points, increase height, and then I would write minus 20 centimeters. And now these points were moved down by 20 centimeters. Right. The second thing is water. So if we have a big body of water and we do a mapping there, sometimes we will see a little bit of the ground through the water, but the ground there is not accurate because the light, of course, breaks on the where the air and water meet. So underwater photogrammetry only works as underwater photogrammetry. You need to have camera underwater as well. Okay, so that was the question that we had. Any other question at this point, maybe? If not, I can show maybe. So we have 4 more minutes of the webinar. So the program comes along with also we have like recorder integrated into it. So this one allows us to create visualizations of the surveys that we do. So I just defined a path. Let's make it 15 seconds long. Let's see how that flies. Probably still a little bit too fast. So, you know, we create this very stunning 3D data. We need to share it with our customers. The simplest way to do that will be to record a video. So if I go here into record a video, set this one to slightly higher resolution. It's now recording the video, and now I will change the display into height map. Show also the full 3D mesh, go to mesh, turn off point cloud, turn off height map, turn height map back on, change the color of the height map. So whatever we change here will be visible in our video. Turn the height map off, shading off. And I guess 15 seconds was a little bit long. Increase point render size. Decrease it back. Turn off non-ground points. Like that. Of course, again, now screen capture is running for the GoToWebinar, and also screen capture is running for this one. It's running slightly slower, but it will finish soon. And now here we have our video of the site that we just recorded. Right. So I see that we don't have any additional questions. So Eric, do you want to say something before we finish this presentation?
Yeah, I will say some words in Latvian, if you don't mind. Okay.
Perfect.
Jā. Paldies visiem. Paldies, ka noklausījāties tādu nelielu ieskatu par 3Dsurvey programmatūru. Kā jau teicu, webinārs bija ierakstīts, varēsiet apskatīties vēlreiz, un jā, jūs varat ieiet mūsu mājaslapā un notestēt, lejupielādēt un notestēt šo programmatūru 2 nedēļas bez maksas, un jā, varbūt nākotnē noderēs, un jā. Un, protams, ja ir kaut kādi jautājumi, droši varat arī rakstīt e-pastā man vai uz info@gpspartners, atbildēsim, un, ja vajadzēs arī kaut kādu konsultāciju, droši rakstiet. Paldies visiem, and thank you all, and thank you, Vīt, for good presentation of the product and good samples of the data.
Thank you, Eric, and thank you for inviting everyone to the webinar. If you have additional questions, you can also check the other webinar sections in our website. On our website, we also have free trial available. So don't worry about using the free trial. If you use free trial and you want to try it again, you can always send us an email and we extend it. So there is no problem there. Our website is called www.3dsurvey.si, or you can just Google 3D survey. So that will be...
one more, Vít. I just have one question. about data. Par sagatavošanu ADTI specifikācijai. Nu, pagaidām tas softs nav tik advancēts un nav iespēja sagatavot, bet tieši sazīmēt līnijas punktus un izeksportēt mikrostācijā, kur varbūt pārveidot ADTI specifikācija ir iespējams, bet tieši šajā softā nē. Es nedomāju, ka pagaidām tas ir tāds tieši rastēšanas softs. Varbūt nākotnē būs iespēja, bet pagaidām tas vairāk ir tieši fotogrammetrijas softs ar iespējām papildus kaut ko izdarīt, nu tieši projektēšanai. Yeah, Vit, thank you. There was one question about in Latvia there is some specific data format in CAD for topography and so on, and there was the question if there is this like a specification in 3Dsurvey software. So I answer it in this question. I think in the future we can talk about this, and I will tell you more about this or country specification. Maybe we can do something for our surveyors and maybe help.
Okay, very good. Just one thing to show. So here, when we create points in 3Dsurvey, we also have the ability to add some points to it, some code to it. So I'm not sure if that's helpful, but this code, it can be a word or it can be a number. So sometimes maybe code 12 will mean, for example, the edge of the road. So I'm not clicking very accurately now. So when we go now data, save CAD as, and we save these points into a TXT format, for example. Not sure if that helps, but it might. So here we can then select what I will say I want to save point code as well. Space will be separator, press save. So now the points also have this information. So if you need to create some points with some special designations, you can maybe use this functionality. Not sure if that helps. Just wanted to show it. Okay. In any case, thank you for joining our webinar. And looking forward to seeing you in the next editions. Bye-bye for now.
Bye-bye. Thank you.
Thanks. Bye.